Okay, so this is lesson number 4, Algebra 2, Unit 4. And this is the question about having rational inputs. That means you're going to have y is a raised to times b raised to x, where x could be p over q. So it can be any fraction like this. So let's see let's walk through uh, some of the activities. The first one is you're supposed to do this mentally. What is the unknown exponents? The first one is, so the first one is 5q equals 125. So what number? So that means what is q? So that the answer is 125. And then from the previous knowledge, we know that the only possibility is 5 times 5 times 5 is 125, right? So that means 5 raised to 3 is 125. That means Q has to be 3. That's it. I think many of you have it. Hopefully everybody has written down. And one is Q. There's another way to do this also. You could also write like this. 5Q is 125, and then you can say, okay, we can write this 125 as 5 raised to 3, and then you can say when the bases are the same, so both have the same bases, then the exponent has to be the same, so Q has to be the same. So for this to be equivalent, both left, right, and the base is already 5, so Q has to be 3. Okay, so that was question number 1. Let's see question number 2. So question number 2, in both cases, the left and the right, you see instead of, okay, so the second one is 1 over 5 raised to r equals 1 over 125. Same thing, we can write this as 1 over 5 raised to r equals 1 over 5 cubed. See now? So which is same as this could be equal only if r has to be 3. That's the only way it is possible to be equal. Or you could also write this as instead of this piece can be written as 1/5 raised to r, and the second one is 1/5 raised to 3. So the base becomes like the half, 1/5, 1/5. So r has to be equal. So this is another way to do. Or you could also do third, another approach in order to get the answer is, let me write that also, is if we have 1 over 5 raised to r and 1 over 125, it means we can write this as 5 raised to minus r. This is the negative exponent property. And this one, which is already 1 over 5 raised to 3, can be written as 5 raised to minus 3. So the bases are the same. So minus r equals minus 3, and dividing by minus 1, you get r equals. So different ways to do. Okay. Now look at the next piece. The next piece is 5t. So 5t equals 1. The first thing is, we know 125 is 5 raised to 3. Okay. So that means we can write the 5 raised to 3, which is in the denominator. That means if we have 1 over a raised to p, then this is same as a raised to minus p. So we can write that and say, okay, this is 5 raised to minus 3. Now both the bases are the same, so t becomes minus 3 and you're done. Okay, so that's how it is. And you can compare the first and this. In the first case, it was 5 raised to q. 125 was there was 125 divided by 1, but this one was a reciprocal. So you can see that the t has to be the negative. So the question is, what is this, right? Now this looks a little confusing. So it is 125 u equals 5, right? Now this 125, watch this. This is the u part, right? And this 125 is 5 raised to 3. So let me write this as in the blue color. which is 5 raised to 3. Okay, can you write this one step here? So instead of 125, so 125 is 5 times 5 times 5, which is 5 cubed. So you just replace this 125 as 5, which is equals, and this is 5 raised to 1. Now, you can use another power of power exponent property, that is this equals this. So this can be written as 5 raised to 3u, 3 times u. So you just multiply these two pieces and you get 5. Now both have the same base. So the bases are the same. So this one, the left side and the right side, the red color, the base is the same. So the exponent has to be same. So 3u has to be equal to 1. And then you divide by 3 and you get u is 1/3. So this is one way to do. Okay. Mario? Sai, did you see? So that's one of the strategies we can use. But then, as we are uh, another way to show is, if you see this 125, there's a u, right? Equals, and it is 5. So 125 um is 5 raised to 3. That's one thing. As if you see this, do you have to write all those steps, or you all? Now there's a 5 that, so from the back of your knowledge, from previous knowledge, you know that cube root of 125 is 5. Now what it means is 125 raised to 1/5, like this. Sorry, one third. So 1/3 is 5. See how it is? So that's how it's this this 5 that you see on the right side, it is the cube root of 125. So that means that u, which is here, this is 1/3 here. So if you know directly, that's how it is. So your u becomes equals to 1/3. Is that correct? Nobody saying yes. So this is another shortcut. So you have to get used to this. What is this cube root of 125? And both are the same thing, writing. And I always said that if you have cube root of b, it is same as b raised to 1 over 3. So this piece is the same thing. You can use it for any radical like this. B is b raised to 1 over 4. Whatever the index here in the V shape, can you see the V shape there? That V that goes in the this red and goes there, here. If it is n, then it is n here. So that's in general always true. Okay, let's go to the next. Now 4.2 is you see the map there. It's the population of a state in no, it's a country. Nigeria is a country in Africa, right? Can you see this? Africa? This is Africa. So that's the country. See that the little island on the right side is the Madagascar, and at the bottom is South Africa, I think. And then above that, there are all Zimbabwe, Kenya, and all those things. And the top left, Ethiopia, Eritrea, then Nigeria, Angola. There are so many countries in Africa, right? Anyway, I don't know everything, but let's go. What is he talking about? Watch this. Loud and slow. Yeah. Express the population of Nigeria, F, D, in millions of people, G, decades, and 1990. Oh, no, I want you to read this in 1990 that way. In 1990, Nigeria had a population of about 95.3 million. By 2000, there were about 122.4 million people, an increase about 28.4%. During that decade, the population can be reasonably molded by an exponential. Thank you. Okay, so now the best way to do this is what I want you to do. Let's make a table there. There you can make a table like this. Can we make? So to understand this, so number of decades, the numerator is D stands for the number of decades. So that's how many decades passed. And this is in the year 1990. Okay. And then 2000, and then 2010, and likewise. Okay. So the beginning is when you say 1990 is that's when the population was measured. So they checked that in the beginning zero, the number of population, and they use FD. So this is your FD. FD represents, and this is D. So D means number of decades since 1990, and FD is the population in that after so many decades, like it can be 0 decade is in the beginning. So they gave us already that the population is 95.3 here. So this is 95 point. So 28.4 is 0.284. So that goes right here. And the answer becomes B is 1.284. See, so you already know that's the growth factor. And the question is express the population of Nigeria, which is FD in millions, D decades since. So we want to know the population in the year. You have to create a model, and with that we'll finish. So you write down F of D is so the population in the beginning that's the population in the beginning, which is 95.3 million, and then you go on multiplying by the growth factor B, which is 1.284, and then raised to the power number of decades. So if it is decades, you just put a D here, correct? So that's the answer. So this is the answer for the first part. But if they ask you a question, look at the next question, write an expression. What about in 1996? Now, where is 96 in the table? I can break this into 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 10. See, 96 will be 1, 2, 3, 4, 5, and 6. This is 1996. So basically, you're dividing by, so f of, so 6, so it's 6 years since 1990. See, so 1996 minus 1990 is 6 years. Now 6 years, you have to convert this into decades, right? So 6 years, if I want to convert to decade, every decade is, one decade is 10 years. So that means this crosses out and you get 6 over 10, and 6 over 10 is 0.6. So I'll just write 6 over 10. So this is 6 over 10. So I will continue this. Make sure when you go home, check the video. Okay, I will complete all those activities. So if you see, we did the first part and the second one. This equals. So this is the second question. Write an expression to represent the population of Nigeria in the year 1996. That means if you see this, I also split this in the table. Remember the table, this piece was blank. What that means is I split into 10 parts. So that means in the how many years from 1990, and you can see 1 year, 2 years, 1, 2, 3, 4, 5, and 6. So that's what it is. This is the piece I'm talking about. This is the year is 1996, which is we need to figure out the population, and you're not supposed to write the answer, just an expression. So you write this. So it is 95.3 is what the population was, and then you multiply 1.284 raised to the power. What should I write there? So what is D means? 6 over 10, right? So that is 6/10. Okay, so this completes the, so of course it is 6 years since 1990, but they want to write an expression to represent the population of Nigeria in 1996. That completes that question. And the next question they're asking is, okay, this question says a student, there's a student who thinks like this. Okay, this is just the student's argument. Population of Nigeria grew at 2.84 per year. Okay, can you underline this? This is what the students think, but do you guys agree with this? Remember in the problem that we seen that the population percent increase was, what was the percent increase? What? 28.4%, right? So what the students think? This is for 1 decade. And 1 decade is 10 years. So, okay. So that means, so what does the student think here? What he does is he divides this 28.4 in divide by 10, so because he wants to know in a year. So, and that's how he thinks is 2.84. But is this correct? So explain or show why the student statement is incorrect. Just let's imagine if this was, he was correct. So I would say if, so I'll write here. I want you to write if 2.84% per year was correct. So let's put it like, if he was right, imagine if this was here, then the growth factor will be the growth GF, which is the growth factor per year would be, so I want you to write this, per year is 1 plus whatever that, this R. So this is the new R. Now I'll just write new R, which is R, which is 1 plus, uh, and when you write 2.84%, it means you are writing one, it is like 2 2.84 divided by 100, which is 0.0284. So which is 0.0284, like this. So the growth factor becomes 1.0284, like this. Now, because let's say this is 1990 and this is 2000. Okay, so this is 0 and this is 1. And here I'll put like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to know this piece. It is 1 year. So if it is, that means in 10 years there are 1, 2, 3, 4, 5. There are 10 times. So we have to do what is. So if this was the, I think yeah, this is the growth factor per year. Then we need to know, do we really get from here to here? It was 1.284. Remember the one that we did, check your table. So if I multiply 1.0284, if I do this 10 times, so if I do 10 times like this and use the calculator, if you do this on your calculator, you can check, put it on the calculator when you get time, and you get 1.3. So it is 1.3223. So this, so if you get this means there is an increasing. So there is a percent increase here. Percent increase is, so here the percent increase will be this is the number that decide, which is 32%. That's like 32.3%, which is not the same as the one that they gave us in the problem, which is 8.4%. So the student is wrong to say that so this piece, no, he's wrong. He can't say this because if he says this is correct, then you end up getting wrong answer for 1 decade. See, in 1 decade, it is growing by 28.4%. So that is false. So this is the explanation to show why the student is wrong there. Then find the final correct growth rate. So we need to know what is the right growth rate then. Let's do that. Now for this, remember the trick is f of f of 110 per year. Okay, we want to know per year, right? So f of 1/10 equals, this is for 1 year, population in 1 year. This is 1 year is, in the beginning it was 95.3 and times 1.284 raised to the power 1/10. See, because it's like 1 year, 1 out of 10. So 1 year out of 10 years. That's the understanding. So this piece is so important. So that means you can work out. So we'll have to work out what the heck is this. Let's see. Give you the answer already. So this is what the growth factor is. So if you put this on the calculator, that is 1.0253. So on the calculator, if you put this uh, 0253, and this means it is 1 plus 0.0253. That means your growth factor becomes equals 2.53%. So this is the right answer, and this completes uh, all the three questions. So for each year, it is 2.53%. So that's the correct answer. Now I will continue this. So, so, so this is what the main answer for the growth factor is. Uh, the growth factor is 1.284, which is the factor for 1 year. But then I wrote it as one point. Okay, let me show it one more time because this is just too much of stuff here. So let me clean this. Okay. So I was saying that for a growth factor for 1 year. So this piece that you see here, this is the growth factor for 1 year. 1 year is 1 year after 1990. So that means this is growth factor here is 1.284, which is raised to 1/10. And if you put on the calculator, you end up getting 1 point, which is 1.0253. So what this means is it is 1 plus 0.0253. It means this is what helps us to know, which could be written as this piece. So 0.0253, if I multiply 100 and divide by 100, so you get 2.53 divided by 100, which is 2.53%. So each year, the percent increase is 2.53. So that takes care of the question number B part. Also find the annual growth rate. Okay. So not only the annual growth rate. So this is the growth rate annual per year. Okay. But the one that I showed here is this piece is the percent increase annually. What is the So I hope that makes sense, and let's go to the next activity. So the next question is 4.3, a healthy So in a healthy adults, caffeine has an average half-life. So this is very important. Average half-life of about 6 hours. That means what this means is if I try to draw this, so let's see, that means the first part is the number of a 6 hour period. So every 6 hours, so I put this is like a zero, let's see. Okay, and this is one. Now, what does one stands for? This is one. This one stands for 6 hour period. 6 hour period. So that means these are number of. So I want you to draw this table so that you understand what's happening here. Is number of 6 hour periods, and you can call this also is like a maybe put a P. P stands for 6 hours. And this means uh, how much amount of caffeine in the. So in the beginning, it says, let's suppose the healthy man consumes a cup of coffee that contains 100 milligram. So in the beginning, there is 100 milligram here. And then this 100 milligram, this becomes a half-life of 6 hours basically means after uh, 6 hours pass. That means one group of 6 hours pass. That means it becomes half. That's what that means. Now remember this again. I repeat, this one stands for is P. So this is like P is zero here. That's like zero. This is P equals one, which means 6 hours. So after 6 hours, so the growth, so the decay factor. So what is that decay factor? So I call it, let's call it a B, which is the decay factor. So this is the decay factor, and this decay factor here is B is half. Of course, it is 0.5, right? And it's the same as, can be written as 1 minus 0.5. Basically, this means it is 100% minus 50%, correct? Which is B is, which is 50%. So B is, sorry, this, so this means 50% goes away. So this is that decay rate. So decay rate is different. So decay rate is 50% because 50% goes away. So there is a drop drop of amount of caffeine in the blood, which drops by 50. So what retains is, so B is actually what it retains. So the growth decay factor is basically how much of the medicine stays in the blood. That's what that B is. So this B is half, and I hope it makes sense. Okay. Now the question is, based on this, let's see what's given to us is, first question, each of the following expression describes the amount of caffeine in the man's body some number of hours, so they give it after so many hours, after consumption. So how many hours after consumption is the question. So he's asking us consumption. The first one tells you the way we can create, see this. So let's create this. So let's model an exponential function. Create exponential function, which is y is a raised to b raised to x. But in this case, the a, which is in the beginning, and y is the amount of medicine. So we can write also medicine m of p. It means the amount, or we can use instead of m, let's put it a uppercase, amount of medicine p periods of 6 hours. So that means the A of P, that means the amount of medicine in blood, or the caffeine, sorry, amount of caffeine in the man's body is, in the beginning it was 100. So I want to create this so that we really understand what's going on. And the decay factor, that's what we already did here. B is that's the one, B raised. So this is half and raised to the p. So the p is 1. So raised to p. So this is, and remember what does p stands for is, p is number of, p stands for number of 6 hour periods. So every 6 hours, so the amount of caffeine becomes half. Now the first question is this. So there is a p equals 1. So if p is 1, I don't have enough room here. Okay, here. So the first one is, so this means p is 1 here. So that means, what is that means is p is 1. That means that there are one period of 6 hours. This means one period of 6 hours. So that means this p equals 1 means 6 hours after the medicine, after the coffee is taken. Now, what is the meaning of this 3? P is 3, B is how many hours? That means, let me write it out. This, oh, here I can write. So this means P equals 3. That means 3, so that means there is 3 6 hours, 6 hour periods. It means total number of hours. So 3 periods means 3 times 6 hours, which is 18 hours. That's all it means. This basically means P is half 1 over 6. So 1 over 6 means 1/6 of 6 hour period. So that means it is 1/6 of 6, which is 1 hour. So that's like 1 hour. And the last one is the directly given. Okay. So instead of P, I think they already give you T hours. So that means this basically means, so in this case, T is same as the P is the amount of caffeine after T 6 hour period. So it doesn't tell you what number it is. So it means the T stands for P, which I think I should have taken this P as T, but I hope it makes sense. Okay. So that takes care of this question to understand. And if you want to know, figure out what is the, so there's the second question here, and I try to change this. I think I did take, first I took P here. This was P, and P is same as the number of 6 hour period. Okay, so the group of 6 hours is considered uh, like a 1, 2, and so on. And this one I wrote FT, even though I had taken M of P, which is same as, now I'm using back to T because that's what they are giving in the problem. Or maybe instead of hours, so T stands for, so what is T stands for? 0, 1, 2, 3. So each time it is like 6 hours. This is like 0, right? This means it is 6 hours. This means it is 12 hours. So understanding is very important. Is when you say T equals 3 means this is 18 hours and so on. So H equals to number of hours. Now, write a function g to represent the amount of caffeine left in the body H hours after it enters the bloodstream. Now remember, we want to know how much, let's see this piece, from here to here, we want to know 1 hour. So that's like a hour. So H is 1. So we want to know how much is the medicine stays here of the 100. Write a function. We are supposed to write a function. So for this to know, we do know what is the decay factor. We need to know for 1 year, or for 1 hour, what is the decay factor. Now remember, from for t equals 1 here, 6 period means there are how many hours? 1, 2, 3, 4, 5, and there are 6. So that H is, this is H is 1, H is 2, H is 3, H is 4, H is 5. So H stands for number of hours. Okay, so if the main thing is about, if it is f of t, let's see, this is f of t that we have seen on the modeling is, it was 100 and then multiply by, and because decay factor from here to here is half, so that's like a b is half, so this was half raised to t. This is one answer, right? This is the first function, but we need to create a function g about the function of h. So we want to know g of h. Now what is this basically means? Amount of caffeine h hours after it was taken, right? So this piece we need to know how much is this one. Now for this, the beginning is 100. Okay, that's correct, perfect. But then what do we write here? And this is raised to the power h. Number of hours is h. So what is to be written down here? What is the decay factor here? And you can see I'm going to use, let me use this color to may help us. So that means this is going once, this is going twice. So I want to see the decay factors multiply twice, then multiply thrice, multiply 4 times, multiply 5 times, and then goes to, so 6 factors. So let me call them as B's. If this is B, then another B, then another B, then another B, another B, another B. Okay, so I'm using uppercase B. So B raised to 6 equals is the, because the big one, this is half, right? So the main B is, the lowercase b is half. So this becomes half. So b raised to 6 is half. So if b raised to 6 is half, then b equals half raised to 6th root. Now what is the 6th root? Means 1 divided by 6. So if you get confused, what it means is b raised to n equals, let's see, something a, then b is nth root of a. That means b is a raised to 1 over n. So it's the same thing. So this knowledge is very important. How do you get? So I'm using the same formula right here. This formula is right used here. So the uppercase b becomes 1 over 6. So that means the function here is half raised to, so I made a mistake here. Let me write it nice and neat. So that's going to be half raised to half. So there is a half raised to half. So that's the decay factor. So that means your answer is in a nice, in an organized way. Let me put it 100 times half raised to half raised to 1/6. Sorry, 1/6 here, 1/6 raised to the power t. And that means the question is, this is the final answer, but they're asking you, I think I missed that h. This is h, which could be also written as 100 times half raised to h divided by 6. So that means if you compare this to this equation t, so all you do is t, instead of t, you write it as h equals 6, because number of hours is 6 times how many t periods, how many, so it is this way, h is 6 times t. So if you divide by 6, so it's like this, so t is replaced by 6 by h, and you can clearly see that this t now is h by 6. So that's the understanding. Now the question is, the last one is, the function f represents the amount of caffeine left in T6 period. Explain why this. Okay, so you have these two equations right here. This is the first one. So the question is, okay, let me put the other one. The other one is g of h. G of h is right here. So it's like 100 times half raised to 1/6, okay, and raised to the power h. So that's the, so this is for GH. This is GH. Then we can also figure out this. If you to know this, understand this, I think I just forgot about what is this answer. If you use the calculator and write this number, that amounts to 0.89. 0.89. So this is 0.89. And what does this basically means is it is 1 minus 0.11. See? So that means 11%. What does this means is 0.11 is 11% uh, drops. So there's a drop of caffeine 11% every hour. And what does 89 means? This means 89% stays. So that's the understanding for this piece. Now regarding this 6 is G of 6. Let's say G of 6. So G of 6 means G of 6. You replace, so replace H by 6. You can see you get 100 times this 6 and this 6 crosses out, and you're left with half raised to 1. And f of 1, and f of 1 right here, if I plug in t, f of 1 is 100 times half raised to 1. And you can see both these two answers are the same. So this answer and this answer is the same thing. What basically it says is the amount of caffeine in the bloodstream after 6 hours is same as for the second function, amount of caffeine after 1 6-hour period. So this is 6-hour period. 6-hour period is same as saying after 6 hours. So G of 6 is same as f of 1. So there's one more question they ask also. What percent of initial amount of caffeine do you expect to break down in the first 3 hours? Is it less than 25 or exactly 25 or more? Now, if you see like this, the amount of caffeine in the beginning, let's say this was 100, okay? And I'll write 1 into, this is like 1 6 period, 2 6 period. So this was in the beginning, and this is 50. Then this will be after 1 6 period, and the graph will go through. So then this is 25. So this will be like this. So the graph goes something like this, right? Like this. So the question is the first 3 hours. That means 3 hours will be in here. So this is 3 hours. Now, because 3 hours, this is your t equals 1, t equals 2. So it means if you want to know 3 hours, that means remember f of t was 50 times half raised to t, right? And you want to know 3 hours, that means it is 3 hours. T is 3, so you'll have to divide by 6 because 3 hours is half of 6 hours period, correct? So you have to, or if you get confused to what I'm writing, let's do it like this. 3 hours is, so 3 hours is same as 3 hours times 1 hour period. So 1 6-hour period is same as 6 hours, right? 6 hours. So that means this age crosses out and you get 3/6, which is 3/6 of 6-hour period, which is also half of, so this half of 6-hour period. So t is half there. So when you want to figure out this one here, this becomes f of t, f of, so it becomes f of half, which is equals 50 times half raised to half. Right? So you get something like this. I hope I'm making sense. So it is half raised to half because 3 hours is half of this whole thing. This is one, right? So 3 hours. So T is 6 hours, or H is T over 6. So if I want to know T, I'm sorry, I made a mistake. This is, so I'm taking little time. So H, number of hours is 6 times uh, T, because this is important. And then you want to know 3 hours is 6 times T. So if I divide by 6, you get T equals, you get half. T is, so you get T is half. So that's how I got this half here. Okay. And when you use the calculator, what is that? Half raised to half is 0. You get 0.707. Now what this means is, it means this number within 3 hours, 0.0, this basically means multiply 100 and divide by 100, sorry, multiply 100 and divide, it's 70.7 over 100, which is 70.7%. And you can see this number, 70.7%, is greater than, because they were asking more than 25. So there is more breakdown of the caffeine in the blood. So I hope with this I want to end up, and you can do the cool down. You have to do yourself, and that takes care of lesson number 4, unit 4, algebra 2, all the tasks. Thank you.